This is a crude contact from an old blender. It had a push rod that pushes on the top of these with a button at the top. Because these two metal plates are separated by about 2 millimeters of space, they bent down into each other. And then when you release a button, they spring back, creating a 2 millimeter gap between them. So for a momentary push button switch, it was built into the blender basically. Now we have the switch connected to an 120 volt 8 ohm load, which will draw 15 amps. The switch is connected in series. I'll just carefully give it a push. And as you can see, it makes connection, powers up the load, and then when it's disconnected, it makes a brief arc, but it's interrupted quickly because the zero crossing, when the voltage and current drop to zero in the circuit, it interrupts that arc and allows it to cool off, and the switch breaks it successfully. This was a 120 volt rated contact for this blender switch. It has no problem breaking that arc. But that, I believe, is only because of it is relying on the zero crossing. When that 15 amps and 120 volts falls to zero, that's when the arc stops. Now the switch is in series with an 8 ohm load connected to 80 volts or 82 volts DC, continuous direct current. Now it's drawing only 10 amps through the switch when I press this button. And there's no zero crossing, so the arc is able to continue until it destroyed the switch contacts, at which point it stopped. You can see how a switch is rated for 120 volts AC and 15 amps. Could be totally destroyed by even lower voltage and currents if they were continuous DC. While I was taking this apart, I noticed an arc when I disconnected it. It turns out that the switch didn't burn until the contacts were just destroyed and stopped conducting. It burned until they welded to each other. The copper melted down, bridged the gap, so now the switch was in a permanent on position. So it's briefly connected to a lower voltage and current than it had switched successfully at 120 volts AC. When it was connected to 80 volts DC and tried to switch that, it melted itself, and now it has a permanent bridge between it. It's permanently on. This shows why you have to make sure any switch that's used on a DC circuit is rated for DC. Many switches will say they're rated for, let's say, 120 volts AC at 10 amps, but for that 10 amps, it's only rated for maybe 30 volts DC. The ratings will be completely different. Just something to keep in mind, especially with solar power, battery-powered things, anything that would be dealing with DC. The arc potential is much worse when there's no zero crossing.